Alrighty, so let's start. So I got questions during the break. So about, of course, this is basically, you see that this is the way I draw this indifference curves. I made them in such a way so that, right, so basically we have this here. So it's obvious that you like good X, right? So if you don't like good X, and the government tells you, shall I tax you on your income or shall I put the tax on good X? Which one you would prefer? Good X. I put the tax on, I don't smoke, right? Put the tax on good X. But of course, or on alcohol, just put the tax on rakı. But in that case, you might get, how many people were dead? 14? Because it's too expensive, right? Because of the fake alcohol, right? And then do you remember what those guys were saying? They were saying that please tell them to decrease because that guy is going to drink that anyways. So that's what he says. But if it's too expensive, he'll try to find cheaper versions of it, and then which might end up in very fatal cases, as we have seen. But anyways, if you don't like the good, of course you would tell the the government that, oh, put the tax on the good, don't tax my income. But if you like the good, if you enjoy consuming that good, then of course you would want the government to put the tax on your income, obviously, because here you can make your adjustment, right? Because in this case, when they tax the good X, and if you like X, then what they're doing is that they're artificially forcing you to consume Y. But maybe you don't like Y that much. But because it's relatively much cheaper, you have to switch to good Y, right? But you see, for instance, when they when they put the tax on income, the guy might enjoy consuming more X and then don't have to increase his Y consumption this much, right? So, but of course, as I said, that it depends on, you'll see, the utility function. It depends on whether, of course, it is embedded in the utility function, whether you like good X or not, okay? So just keep this in your mind. This is, a representation of a case of these type of indifference curves, right? Where you like X and such. But you see that that's why graphs are not, they are very informative. They give us the intuition. But in order to show stuff, we need to use math, right? So let's do it, and you'll see that that's why indirect utility functions are useful. And similar logic would apply to a subsidy, okay? If I give a subsidy, how do you think my budget line would change? This time, if I make the price of X cheaper, if I make good X cheaper, then my budget line would rotate inward or outwards. Now it's cheaper, I can consume more X, right? So it would be a similar situation, but this time this guy would go there and you would still show a similar, logic, okay, on the graph. Now, let's actually get some indirect utility functions, and let's actually get some, so let's try to show this via math, okay? Because as you guys are absolutely right, I got some questions, hocam, how do we know this goes through? What happens if things are happening here, etc.? And they're absolutely right. So that's why this indirect utility function is actually useful, okay? So again, we keep on solving examples. Another example. So remember, we actually had the Cobb-Douglas function. So remember the Cobb-Douglas case. And actually your friend showed me, apparently in the Biennale in Istanbul, there was actually so sort of a booth where they show all the functions, 3D, versions of all the functions that are used in economics. So there's actually Cobb-Douglas, all these sort of Leontief, and all these functions. Okay, if you go to you see, so stuff that we see, they're not that abstract, okay? So they can even, of course, most of the stuff in the Biennale are pretty abstract as well, but you can actually enjoy if you go, okay? So basically, we have the Cobb-Douglas function, right? So utility function, we said x to the power alpha, y to the power beta. And for the sake of simplicity, remember we actually derived everything without this condition, but for the sake of simplicity, let's assume that alpha plus beta equals to 1, okay? So remember the demands in the Cobb-Douglas case. So basically it was alpha times I, alpha plus beta, right, px, remember the Cobb-Douglas demands. But here, because this is 1, I'm erasing this, okay? So px and y star is basically beta times I divided by py, right? Remember, these were our Cobb-Douglas demands. Now, what we will do is that let me get the indirect utility function, okay? So what is the indirect utility function? So let's actually solve this case for, I can get it for the general case, but which I will do later, or if you want, I can get it. Okay, so let's get the indirect utility function. So which is basically so let's call it like this. So the indirect utility function would be a function of what? So if I want to write this down, it would be a function of price of X, price of Y, and income, right? I'll keep asking this till the end of the probably semester, okay? And I asked this, so just keep this in your mind, okay? So it would be, so you see that the indirect utility function is a function of all the prices and income, right? And then you know that, hocam, this is when we put these optimal points back into the utility function, right? So let's actually look at this. So what is this? So alpha times I divided by px to the power alpha, beta times I divided by py to the power beta, okay? So this is basically it. And then, so if you write this, this is going to be what? Alpha to the power alpha, beta to the power beta. That looks nice. So it's I to the power alpha plus beta, right? Divided by px to the power alpha, py to the power beta, okay? Now, because alpha plus beta is equal to 1, so I can write this alpha to the power alpha, beta to the power beta, px to the power alpha, py to the power beta, okay? So you see that this is an indirect utility function times I. So this we have times I here, okay? So now, so this is the indirect utility function, okay? So let me actually, suppose we would like to show it in this case. Let's actually consider a case where alpha is equal to 1 over 2, beta is equal to 1 over 2. What are the demands? So for instance, example, demands are x star would be what? I divided by 2px, y star I divided by 2px, right? So this is the case. What about the indirect utility function? In this case, px, py, I. If these guys are equal to 1 over 2, 1 over 2, it's going to be what? 1 over, right? So this is 1 over 2 to the power 1 over 2, 1 over 2 to the power 1 over 2, which makes 1 over 2, right? So this is 1 over 2 times income, and here px to the power 1 over 2, py to the power 1 over 2, okay? So this is a special case. This is the most general case for, you know, Cobb-Douglas, not even most general, right? We put this assumption, and then we just try to show it, for instance, for this case, right? So when alpha is equal to 1 over 2, beta is equal to 1 over 2, okay? Now, suppose, py, sorry, yes. Thank you. Thanks. So, right, so this is the case. Now, suppose, so this is the indirect. So you see that why it's useful. Because then you don't have to, you see that you don't have to draw this graph. Now, suppose we have this. Suppose px is equal to 1, py is equal to 4, I is equal to 8, okay? Suppose these were the prices, and this was your income, okay? Now, before tax, right, before the government taxes you, what was your utility level? So you see that when I give you the indirect utility function, you don't have to solve the utility maximization problem, right? You can just plug these values in to the indirect utility function and get the maximal utility, right? So suppose this consumer solved his utility maximization or her utility maximization problem, and what is the utility they achieve? So if Px is equal to 1, Py is equal to 4, I is equal to 8. So this is, right, what is this? I is equal to 8 divided by 2. Px is equal to 1 to the power 1 over 2, 4 to the power 1 over 2, right? What is this? 2, right? So you see that initial utility level, apparently, initial utility level was 2, okay? Now, let's think of our cases. The first case, suppose government puts 1 Turkish lira tax on good X. Then what happens? What is Px tilde? The new Px is 1 plus 1. What's 1 plus 1? Okay, so 2, right? So it's actually 2 Turkish liras. And then the rest is Py is 4, I is 8, right? So what is the new utility level? You see, this is the beauty of indirect utility function. I don't have to solve the optimization problem again. I just plug these new Px, and then it's going to give me the new utility level, okay? So what is this? So let's call this V tilde with tax on good X. Let's call it like this. So V tilde with tax on good X, what is this? So this is basically V Px tilde Py I, right? So what is this? What is this new utility level? 8 divided by 2 times, but now Px is 2 to the power 1 over 2, 4 to the power 1 over 2. So this is something like 1.41, okay? So this is actually the utility level after this tax. What happens? Obviously, when they tax you, your utility level falls, right? So obviously it's going to fall. Okay, so now, so this is 1.41. Now let's try to do the other version. So suppose the second one, government puts, so let's actually, let's put it like this. So they put the same, put a tax on income equivalent to tax collections. Okay? So this is the other case, right? So these were, remember, these different cases, right? So now, okay, how much the government, how much tax should the government put on the income? We have to compute it, right? So what are the tax collections here in this case? It is T times X, but we have to solve, right? What is the optimal X here, right? So tax collections before was what? T times X. So let's call this X tilde with tax on good, right? So this I have to solve for this X tilde. What is this? So if I need to, so what was the X tilde before, right? So let's call this X tilde with tax on good. We know the optimal X, right? So it was I divided by 2 Px. Is this true? Tilde, right? So it should be Px tilde. So the income was 8. So 2 Px tilde was 2. So apparently the amount of X in this case that you were going to consume was 2, right? Now, apparently, so what is the tax collections? Apparently, government, they were going to collect, in this case, how much tax? 1 times 2, 2. So they're going to tax your income by 2 Turkish liras, okay? Now we figured out, so government taxes income by 2 Turkish liras, okay? Now let's see what's going to happen. So 2 Turkish liras. So what is going to be the utility? Let's check. Right? So what's going to happen if the government is going to tax the income by 2 Turkish liras? What is going to be the new income? So let's call it I tilde, which is I minus 2. I was what? 8. So the new income is going to be 6. Okay? So let's see. With this, let's call this V tilde with tax on income. So let's see the utility level, right? So the indirect utility function was this, remember? So let's put 1 over 2. Instead of income, I'm going to put 6. The rest is the first numbers, right? So 6 as income divided by 2 times, shall I put here px or px tilde? Px, right? Because they taxed the income, they didn't touch price of x. So, okay, so let me write this, so this would be helpful. Px, py, I tilde. 6 divided by 2 times, right? So I have px to the power 1 to the power 1 over 2, 4 to the power 1 over 2, bless you. Okay, so this is basically it. So what is this? This is an easy number. 6 divided by 4, 1.5, right? So do you see the utility level? You see, when they tax your income, okay, your utility is going to fall anyways. There's no escape from that, right? So they're going to tax you, right? So it's going to fall, but it is going to fall less in which case? When they tax your income, right? You see, government is indifferent. They get exactly the same amount of money. But you see, if they put the tax on the good, then you are worse off, okay? So basically what should be the case is you see that if government asks you, you would tell them that just tax my income, okay? So you see that via math, we can show this. So it was harder to show through the, like graph. You have to make some argument, or it should pass through which point and such. But you see, indirect utility function is very useful. You can actually get whatever you want. Much easier, okay? Now, I'm going to do this for the Leontief case, okay? We'll see. What do you think will happen there in the Leontief case? So we'll see. But just keep this in your mind. Here, in this case, consumer's utility, okay, it's going to decrease, definitely. But in this case, there are 2 reasons why consumer's utility decrease, okay? The first reason is that because there is a tax, your purchasing power is less, right? Your real income is less, right? How many goods and services you can buy with your income is less, right? Because there's a tax. So here, okay, so this utility decreases both because your purchasing power decreases, and also the other reason is basically you distort artificially, you force this consumer artificially to go to good Y, okay? Maybe they wouldn't want to consume that much Y, but remember, you push them artificially to consume more Y, okay? But here, so there are 2 reasons here. In this case, they tax your income, yes, so that's why your utility falls. But here you don't play with the prices, right? In this equivalent to tax collections, when you put a tax on income, which is equivalent to tax collections, there is only you only decrease the utility because purchasing power decreases. You do not force the consumer to consume more y artificially, right? By making good x more expensive, okay? Now, so because here what consumer can do is, you see, you give her the option to adjust, right? To the old, like they can actually, but here they can decide on if they like x a lot, they want to consume x and he's going to be happier. So he wants to be able to do that, right? But here you force the guy to consume more y artificially. If they like y, no problem. But if they don't like y that much, that's a problem, right? So you see that this is actually the case. Now, let's don't forget that, right? So there are two reasons, as I mentioned. In the income version, there's only one case that the utility decreases because there's a tax, your purchasing power is lower. In the first case, there are two reasons. There's a tax, your purchasing power is lower, your real income is lower, and good X is artificially more expensive, okay? Now, let's, so this was the case for Cobb-Douglas. Now, let's actually look at the case for perfect complements, okay? The Leontief case. So let's see what's going to happen. So, Leontief case. And again, let's actually get our previous example where we had u of xy was minimum of, what was it? Remember? It was 1y with 4x. How are we writing it? 1y, right? So we were writing it x, 4y, right? Okay, so now let's try to get the indirect utility function here. So do you remember the optimal x and y? So the optimal x, I'll remind you, I divided by px plus 1 over 4 py, okay? And then we're going to have y star, which is I divided by 4px py, okay? Remember, just check your previous notes. This is what we have got. And then, so let's try to get the indirect utility function, which is going to be a function of what? Px, py, and income, right? So this is going to be, if I write this, I need to write it like this, u of x star, y star. So this is weird. So there's a minimum, but you see it's not a problem. I'm going to put x star there, I divided by px 1 over 4 py, and then I'm going to write 4 times y, right? This guy. I divided by 4px plus py, okay? What is this? 4 times I divided by, if I take this part below into 4 parentheses, px plus 1 over 4 py. These 4's cancel out. This guy is equal to what? Let me write. Minimum I divided by px plus 1 over 4 py. I divided by px 1 over 4 py. They are the same. Are you surprised? No, right? That's how we solved. We said that this guy, right? Remember how did we solve this? We said x should be equal to 4y, right? At the optimal points, x should be equal to 4y because these guys should be consumed at these fixed proportion, right? So that's why, obviously, this guy and this guy would be equal at the optimal point, right? They would be equal to each other, okay? Now you learn for the indirect utility function, you can either use this guy or 4 times y, okay? So now what is the minimum of these guys? Oh, it's a very hard question, right? So what is it? It is, what is it? It is, right? So this is I over px plus 1 over 4 py, okay? So the indirect utility function for the Leontief case, right, that we considered, of course it's a special one where we put numbers for alpha and beta, basically. Okay, it is this case. Okay, so now let's do exactly the same problem. So let's try to figure out the initial utility level. Let's try to figure out, these stuff. So now this is no longer the case. So the initial utility level would be what? So let's see. px, py, I. So it is, right, what is this? I divided by px. So I is 8 divided by px, 1 plus 1 over 4 times py, which is 4. This makes 1, right? 8 divided by 2. 4 is the new. 4, apparently, in this case, 4 is the initial utility level, okay? All right, so suppose government puts exactly the same amount of tax, 1 Turkish lira tax. Now let's try to check. So this is going to be 2 this time, right? But this is not the right indirect utility function. So let's see. So basically, what is this? So let's, 8 divided by, now I have to put px tilde, right? 2 plus 1 over 4 times 4. 8 over, so what is this? 8 over. So this is 1 over 4 times 4. 3, right? 8 over 3. Apparently, the utility, so did it fall? Yes, right? Obviously, of course, there's a tax. It's going to fall. Now, let's consider government puts a tax on income equivalent to tax collections. First, I have to figure out what were the tax collections here, right, before. Now, in order to do this, x star with tax on goods. So I know what x star, right, the optimal x, the formula for optimal x. So let me use not this, because it's no longer Cobb-Douglas, okay? We're going to fill all these later. So this is basically, right, so what is x star, x tilde with tax on good? So what is that? I know the optimal x star, so it's I divided by, right, px plus 1 over 4 py. So what is my income? It's 8, right? What is my px? Did I write this correctly? No, right? So remember, this is x star with tax on good. So we were trying to figure out the tax collections here. So this should be px tilde, right? So this is 2 plus 1 over 4 times 4. So this makes 1. So this is 8 over 3. Apparently, tax collections are how much? 1 times 8 over 3. 8 over 3. So now you're going to tax the income by how much? So apparently tax collections are 8 over 3. So you're going to tax the income by 8 over 3, right? These are not tricky questions, hard questions, okay? So that we are all on the same page, right? So here you can put TL. Here, this is an amount, right? This is in units, whatever X is. If it's, milk, it's liters. If it's cigarettes, it's for every pack, okay? So then the new income would be not 2, but it's going to be taxed by 8 over 3, okay? So this is 8 over 3. So this makes 24 over 3. So this makes 16 over 3 Turkish lira. So apparently when you put the tax, right, on income, your new income level is 16 over 3. Okay. Now let's try to figure out this. So the indirect utility with tax on income, my indirect utility function is this. I divided by px plus 1 over 4 py. Okay, which is equal to, so did I write this correctly? No, there is something wrong. It should be I tilde, not px tilde this time, but I tilde. So you said that, oh, hocam, it should be 16 over 3 divided by, what is px? 1. What is this part? Py is 4. So this also would make 1. So 16 over 3, this part makes 2, which makes 8 over 3. Uh-oh, what happened here? What happened? So when you put the tax on income, your utility level will be 8 over 3. When you put the tax on good X, your utility level is 8 over 3. What happened? Huh?
Because you can't allocate between them.
what are they? They're perfect substitutes or perfect complements, right? So you see that what happens is basically, so that's why you ask me the right questions. Hocam, how do you know if we have different indifference curves, things might go in different directions, right? So you see that what's happening here is that when these guys are, don't forget, perfect complements. When you tax the good, there is no such thing that I like X more than Y, or when you put the tax on X, artificially you distort me to consume more Y. There is no way, because there is no way that you can substitute this one good for the other one, right? Then if they tax X, you're doomed anyways, right? So it's going to affect, even they tax your income or they tax your, like the good, every pack of cigarette that you buy. There's nothing you can do. Suppose you like to smoke cigarettes with, I don't know, I don't smoke, so you might tell me, right? So like with coffee, let's say. So for them, they are complements, right? One cigarette with one coffee. And then if they tax the cigarettes, there's no way that, I can switch the coffee and, like I can, maybe I can reallocate stuff. So there is none. There is, because you see your preferences are so rigid that there is no way, there are no flexibility that when they play with the prices, you go to other good or whatever, or you like good X more than good Y, okay? So you see here, it doesn't matter. So this is an important case. So here, it doesn't matter, okay? It's the same. So you see, you should be careful. This is called the lump sum principle, but you should be careful. It depends on whether you like the good, whether these two goods are complements or substitutes and such, okay? So you guys were asking all the right questions to me before, okay? So this is basically the case. Now, let me actually start a little bit, don't worry, and then we'll just, we'll stop. So you see that we have learned everything. Now we have the demand curve. We can even make some policy, right? So during the elections, like before the elections, actually, it was very popular. So you see that you can even come up with some policy recommendations. You can say that if these people like this good, like as if, as in the fake alcohol case, he's going to drink it anyways. How much tax you put on it, it's not going to change anything. He likes it, okay? They might decrease it a little bit, but not too much. So basically, you see that you can even make some policy recommendations, even with the little stuff that we know. Actually, you know a lot, by now. So don't feel inferior to your, macro, like topics. So in micro, there are lots of topics, and this is the basis of everything, even macro, okay? So this is actually, we haven't solved the perfect substitutes case, which I will do, don't worry, in the review session, okay, before the exam. So I'll assign you the perfect substitutes case. You'll work on it, but don't worry, if you cannot figure that out, we'll solve it in the review case. But I can give you the hint that in the perfect substitutes, basically you're going to have a corner solution, okay? So if they tax the good, then you might completely switch to the other one, okay? So we'll see. So it depends if it's, where they're, because even in perfect substitute, it would depend on the price ratio. It could be the entire budget line. It could be you're consuming only Pepsi, let's say Pepsi Cola and Coca-Cola. It could be you can either, so let's just think of it, like by arguments. As you see that I think this is the beauty of, these type of courses. You see that we see math, but at every step we can explain what's going on, okay? This is why we spend so much time, and this is why I try to give you what lies behind it and the intuition behind it, right? Because just math, anyone can do it, but Okay, not anyone, but but it is doable, right? At least these type of math, right? But how you should interpret them, what lies behind it, why that's the case, and you see that sometimes our arguments are actually even it's good for math, right? So that we don't have to. There are ways of solving, for instance, these optimization problem. When you don't have differentiability, you might want to consider all these cases, but you can make a simple argument and it works. Okay. So similarly, for instance, in the case of perfect substitutes, I'm going to solve this later in the review session. But for instance, you have Pepsi Cola and Coca-Cola, and suppose you would like to substitute them one by one, right? So it doesn't matter for you. So if Pepsi is more expensive than Coke, what would you do? Coca-Cola. If Pepsi is more expensive than Coca-Cola, and you don't care at all how whether it's a Pepsi Cola or Coca-Cola, what would you do? If Pepsi is more expensive, you would consume only Coca-Cola. If Coke is more expensive, you would consume only Pepsi. If they have the same price, which is probably be the case, right? What would you do? Then you can be anywhere on your budget line. So your indifference curves would be like this, right? So this is going to be U0, U1. But then your budget lines would be like this as well. Suppose you have a budget line like this. Okay, so this is your budget. Then where do you think you would be? So you see that it would depend on, so we'll see, it will depend on this ratio, right? So in this case, for instance, where would you end up? If your budget line is like this, would you be here? This is your optimal point? No. You can go more, right? So you can be here, still on your budget, but get more utility. But would you stop here? Where would you stop? Right here, where this budget line, and obviously there is a utility, right? So there is an indifference curve going through there as well. So you would stop there. So it will, when you put the tax, it depends how much it's going to tilt this. If it changes everything, you might end up switching to the other good. If it, if it makes you this guy like this, then you can be on any point on your, budget line, okay? Or, it might be, you might still stay consuming on the same good, okay? So on Friday, we'll continue, okay?